Hello everyone. Today we are going to be talking about solving complex equations in the SAT. So, whether it be a fraction or just a simple equation like ax minus b equals c, or in that form, you always need to solve equations in the SAT. So, I'm going to give you a guide on how to solve these. So, the first form you can have is probably ax minus b is equal to cx minus plus d. So if you have this kind of form, you can just move this to this side, like subtract cx, and then you could also subtract b from both sides. So then you could just divide by a minus c. So, or you can just work it out. It's pretty simple. It's not really that complicated. So if we have 3x plus 1 equals 5x minus 2, then this would be, well, if we just subtract 3x from both sides, and then we could just add 2 on both sides, we'd get 3 is equal to 2x, and that's it. So x is equal 3 halves. So you can just do it like that, and then you can just easily find your answer. Okay, so now that we've covered this basic type of equation, let's move on to a more advanced type of equation. Now, in this case, you'll be probably dealing with fractions. So you would have probably an expression over here, and you would also have an expression over here, expression over here, and another expression over here. Okay, so now in this case you would just multiply. So then you would just solve for x. Now these can be quadratics, however, and then you can just easily solve for quadratics. So like if you have something like x minus 1 over 4 equals x over 3, you could just cross multiply, and that would be 3x minus 3. And then you could easily solve for x, and x is 3. Negative 3. So, yeah. So those are pretty simple. Just cross multiply and you're good. So, now what else can you do? So, if you have a quadratic, you can just use the quadratic formula. Or you can factor it. Now, if you get something like log of some expression, right, equals something. Notice I'm abbreviating expression as EXP. You can use inverse functions here, and you could just say 10 to this log is equal to 10 to this exponent. And that would equal the same thing. That would mean the same thing. You could just cancel these out, and then you could solve for x. So that's how to solve for that. And okay, so what else can you have? Let's say you have something like an inverse function. So Now, you could have the first simple type. You could have like something like 3x plus 4. And then you could just say, okay, well, if we say this, if we say this guy is y instead, then we could just take 1/3 of both sides, divide both sides by 3, and basically we're trying to solve for x. If you want, you can just swap the variables. And now you can just solve for y. So what I like doing is just multiplying by 1/3 on both sides and then subtracting 4/3. So you would just get 1/3 x minus 4/3, and that's your answer. So, yeah. So you might also have some other things like the distributive property or something that might even use most of these. And honestly, it's not that hard if you just expand everything, simplify everything. Now notice one type of equation that might seem hard at first, but it's pretty easy. So let's say we have something like x minus 6x minus 7 over x minus 4. So now you might actually x plus 1. So you might be like, okay, now what can we do in this case? Like, you could have this expression anywhere, right? Even if it just asks you to simplify this. Now you might be like, okay, well, I have a quadratic over simple term. I can't simplify, right? But here's the thing. You can just factor the top expression. And then just cancel. And that works. Well. Now, if it asks... now, be careful, really careful with this, though. If you try to graph this function, you might be like, oh, it's the same graph as x minus 7, right? But at x equals 1, x equals -1, it wouldn't work. Now you might have seen a graph like something like this, and then they have a dot here, they have like a circle here, and then like that. That means that the function doesn't exist. It's just like, it would be there if it would exist. So what you could do is you have your line here. This might not look like your x minus 7. And then you have a dot here, and then you just go like that. So that, and also in the domain, all you need to say is x doesn't equal -1. So that's how you can solve this. Also, one useful thing is if you can remember that x, or let's just say a and b. So a plus b squared is a squared plus b squared plus 2ab. Similarly, a minus b squared equals a squared plus b squared minus 2ab. So you could remember this, and another useful thing is a plus b times a minus b. This is equal to a squared minus b squared. So if you keep all of these in mind, and also the reverse works as well, so you could just use any of these and to simplify any expressions or expand anything. And yeah, that's your guide on the SAT for solving complicated equations. Thank you for watching this video.